Okay, so we have a 2008 Ram 2500 HD Cummins engine, and it's here today for the transmission not shifting into gear when started. It's got a tuner in it. It's got 386,000 kilometers on it. He also mentioned that the speedo doesn't work, the ABS light is on, and his engine brake doesn't work. But those were pre-existing conditions prior to the transmission problem. Now, I know it's tuned, but that shouldn't affect the transmission, at least negatively. So we're going to hook the scanner up to it and see what kind of codes it's got. So it looks like it auto ID'd. And we'll display fitted systems, and we'll do a code scan. Start with that first of all and see what comes up. Right here he's got an aftermarket fuel pump running. Lost communication with ABS. Transmission controller requested the MIL. We'll pick up when we get to the end of this list here. Okay, so here's what we got. Lost communication with ABS. That would explain the speedo. Transmission control module requested MIL. Cooling fan control circuit is open. Vehicle speed sensor 1 performance. Fuel level circuit. I notice his fuel gauge reads empty, so he's probably got a faulty fuel sender. And in the transmission, line pressure high, inadequate element volume, 4th clutch, hydraulic pressure sensor circuit high, gear ratio error in 1st, 2nd, restricted manual valve in T3 range, airbag codes, central gateway fuel pump control circuit. Yeah, all kinds of fun here. Well, we're going to start by clearing all the codes from all of the computers and see what comes back. So it says it cleared codes from 10 controllers. I'm going to say OK. Go into engine and see if there's any codes that have returned so far, and nothing. So we're going to start this thing. Well, that was quick. Focus. Hydraulic pressure sensor circuit high. Let's see if it goes into drive. Lost communication with ABS. They're just adding on. Goes in reverse. Goes forward. So we're going to drive it in the shop. So looking at data here, I see the line pressure sensor voltage at basically 5 volts, 4.98, which in my opinion would be out of range. So we'll have a look at what sets that P0935 code. That's what it was. P0935. We'll look at what sets that code and what the electrical circuit looks like. So here's the troubleshooting chart for P0935 line pressure sensor circuit high. So it says the line pressure is electronically controlled by the transmission control and is measured by the line pressure sensor. Desired line pressure is continuously being compared to actual line pressure and is regulated by electronically changing the duty cycle of the pressure control solenoid. So what does it do here? Set conditions. The DTC will set if the monitored line pressure sensor voltage is greater than 4.75 volts for 0.18 seconds. Not 0.2, 0.18. And what will it do? Is it active? Yes, it is. Go to 2, check the PCM and the wiring. Turn the ignition off to the lock position. Remove the ignition switch feed fuse from the TIPM. Remove the ignition switch feed fuse from the TIPM will prevent vehicle from starting in gear. The ignition switch feed fuse must be removed from the TIPM. Failure to do so could result in personal injury. Install a transmission simulator. Well, isn't that special? We'll just go and picked that off the shelf over here, this Miller Tool 8333. Oh boy. Set the rotary switch to each of the line pressure positions. The reading should be within 2 psi, whatever. So we obviously can't use this troublemaker chart because I don't have this line or this Miller simulator. But let's have a look at the electrical circuit. So here is, that's the toll hall switch. Where's the pressure? Oh, here we go. I think these are common for the pressure sensors to fail. This transmission has been replaced a couple of times. So if it's seeing more than 5 volts on this, now that could be an open circuit, depends whether this has a pull-up resistor or not in it. I think we're going to check continuity of the wires from the PCM to the transmission. Let me look at this for a minute. So I figured it'd be easier to go on Identifix and see if somebody else has backwards engineered the way to diagnose this thing without obviously the Miller tool. Here's an example. Line pressure sensors are very common. I think I've actually changed one myself. I think it's on the valve body inside the transmission. Check the voltage at the line pressure sensor. The yellow pink wire should have 5 volts on it with the key on. The dark green wires should have very close to 0. This is ground. So let's have a look at this case on Identifix. The yellow brown wire should have about 0.5 volts when backprobe with the engine idling, not 4.9. As the RPM increases, the voltage should increase with the transmission line pressure. I wonder what it would read with the key, with the connector unplugged. Have a look at the schematic here. So there's the connector view for the line pressure sensor. I was wrong. This one's on the outside of the transmission, which makes it kind of nice. It's on the right hand side, passenger side. I think it's behind a heat shield. Mind you, this has been modified, so who knows if the heat shield's even there. So that gives us an easy access to do some testing at it. So we're going to put this up in the air and have a look visually at the connector. I should be able to jumper the signal voltage to ground and watch what the data does on the scan tool rather than go through a whole bunch of other types of testing. We'll have a look at that. So there's the pressure sensor right there on the side of the transmission. Normally there's a heat shield beside this, but it's obviously not here because this has been replaced. But I don't think that's the problem. I don't think it's heat that's affecting it. But nevertheless, one of these wires is 5 volts, one of them is a ground, and one is a signal. And I'm going to determine based on the schematic which is which. What I'm going to do is turn the key on, monitor the pressure sensor voltage with the sensor unplugged. Now it'll either go to 0 or it'll stay at 5 volts depending on whether it has a diagnostic resistor in the computer. Either way, if I take the 5 volt signal, the ground wire, and jump it to the return signal wire, the voltage should go to 0 if the wiring is fine. If not, it'll stay at 5 volts. So we'll have a look at that. So here's the circuit here. This square box at the top of the page is the line pressure sensor. The 5 volt supply is pin 2, which is yellow and pink. The signal is yellow and brown, and the dark blue and dark green is the ground. So we're going to jump this wire, pin 3 to pin 1, and expect this voltage to go to 0 if the wiring is okay. Interesting, the value is still live with the key off. Well, that's nice. At least I don't have to listen to that stupid fuel pump running with the key on. So I'm going to unplug that connector. Okay, so now it stayed at 4.98 volts. So we're going to have a look at the schematic and see which wire is which. So that pulled the voltage down to 0, so that tells me that the wires to the sensor are good. I'm just going to verify that 5 volt reference is there, and that would theoretically indicate a failed pressure sensor. So there's the voltmeter connected to the 5-volt reference wire, and it reads 5.01. On the signal wire I have 5.01 when it's open as well, which means the computer contains a diagnostic resistor. So this would be why it was setting the cooling fan control circuit code. It's unplugged. But I noticed the fan blade is completely locked. So either the fan hub is seized, but nevertheless it needs a new fan clutch. Chances are now these terminals in here are compromised because they've been left exposed to the elements. Yeah, they look pretty. This one don't matter, you're going to get it with the fan hub. But this one here, probably going to need terminal repairs in there because of that. And I see he's got front axle seal leak on the right side, left side seeping as well. And if you're going to do one axle seal, you might as well do them both, because you got to pull the differential carrier out and both axle shafts out anyways. These axle seals are in here inside the housing, but that's a job that he can do. I suppose we'll look at the ABS quickly to see if there's power and ground to the ABS module. So the ABS module lives behind the battery under this maze of wiring here. In fact, that's the ABS connector, if I'm not mistaken, right there. But before we go there, we're going to check to make sure that the fuses that power the ABS module are good, and we're going to make sure we have no communication with it, because there was communication codes against it. So we're going to try to scan the anti-lock brake system. This is a 4-wheel anti-lock brake system, and we have no communication, as I suspected. So that would explain why the speedo doesn't work, because the speedo signals are based on wheel speed sensor inputs. Any one wheel speed sensor input to this ABS module gets passed on to the PCM, either directly, if I can't remember, either directly or indirectly across the network. So we're going to look at the schematic. So here's the electrical diagram for the power supply to the ABS module. All-wheel anti-lock brakes. Shows fuse 30, fuse 13, and fuse 18. I'm going to print this diagram. And they feed power directly to the ABS module. Grounds on pin 16 and 45. Well, we'll check for the fuses first, and then we'll check the grounds. Yeah, that's what we're going to do. So these are the 3 fuses. This 15 amp fuse. Let's make sure this test light's working. This 15 amp fuse here, this 40 amp fuse, and this 25 amp fuse. So the 25 amp fuse is good. 40 amp fuse has a cover over it, so we can't test it without taking the cover off. And the other one requires a key on. 15. Oh, look at that. Power on one side, but not the other. Could it be that simple? Well, we'll pull that fuse out and change it. So now we'll go back into the diagnostic suite and try and communicate with the ABS now. Look at that. Lost communication with TIPM. Lost communication with ECM. Well, let's clear those codes out. Now, just because the fuse was blown, you should actually investigate why it might have blown, see what other circuits, what other things are on that circuit. But we'll have a look at data now and see if we're getting data out of it. Right rear wheel speed, front wheel speed. Oh, they got them all on this side, which sucks because I can only put 3 data parameters at one time. One of these should be, well, we'll see if the speedo works on the dash. Okay, I'm going to start this thing and put it in drive. Well, imagine that, the speedo actually works now. Obviously no left front speed signals because I got it on the hoist. So we'll have a look at what that 15 amp fuse feeds. So this 15 amp fuse, actually that wasn't it. It was fuse, what the heck? Hang on a second. So I see why I was confused. It was fuse 30 and it was actually a 15 amp that was in there, but it calls for a 10. So on the 6.7 four-wheel drive, goes to splice 00022 and then it goes to the ABS module, but where does that splice go? So we need to go to diagram 8W13-9. Diagrams by number, 8W13-9. This will show everything that uses that particular fuse. Blow this up. Fuse 30 right here. So it's only live with the key on, except Power Wagon 6.7. That still doesn't show anything. It shows splice 022, but it doesn't. Oh, I got to go to 8W30-40. These aren't hyperlinks, so I got to go back here. 8W30-40. Only a few diagrams. There we go. Okay, so I forgot what circuit number that was now. Circuit number is F960. That's this circuit right here. F960. So it feeds ignition switch output to the O2 sensor module. All that stuff's been defeated. It feeds diagnostic port data link. No, it doesn't. No, it does not. Anti-lock brake module and this O2 sensor module. Now I know that that's probably been defeated because I see that's got an EGR delete on it and a number of things are missing, but where are those connectors hanging and are they compromised? See if we can find out what else feeds off of S022. So there are two connectors in that circuit, C130, and that one is a big bulkhead connector. That one's at the back of the engine bay, and it's circuit F950. Wow, I missed it. It's supposed to be F950. F950 it looks like, or maybe 960, but I don't even see an F here. F348, oh there it is. Fused ignition switch output run start. A41. So 40, 41, where's A? Oh well, one of these. And the other connector was 108. And where is that located? 108. Back there on the passenger side bell housing area. And the actual oxygen sensor module, that would be down on the exhaust. I'm going to have to find that and see where that is. So here's the oxygen sensor module. It says it's located under the vehicle. It's bolted to the outer side of the right frame rail. There's a picture of it right there. So at least we're going to put it up in the air. We still got it on the hoist. We'll have a look at that and see if there's anything obviously wrong with that connector or the wiring to it. If we can't find anything, I'm just going to tell them to watch for that fuse to blow again. And it's technically supposed to be a 10 amp fuse, not a 15. So we'll talk to them about it. So that ignition feed wire is one of these ones coming in here at this oxygen sensor module. But everything has been disabled here, disconnected. Connectors for the sensors have been eliminated. So we don't see anything obviously wrong with the wiring. Heaven help these guys if they ever have to put all this shit back together again because of the emission police. They'll be in trouble. Oh well, we're going to leave it at that for now. Okay, so we have a new sensor this morning. There it is there, right from Chrysler. And we're going to put it in. I've got the key on right now. I'm looking at data. And before I install this sensor, I'm just going to plug it into the harness and the reading should go realistic. That would have been another way to confirm, obviously, that the wiring is good, is simply plug in a good sensor. There it is there. So I'm just going to go underneath the truck and plug it in. It's unplugged. Now it's plugged in. That's better. As I was reading in the literature, it said it should be about 0.5 with obviously no pressure on the sensor. So we're going to install this sensor and clear the fault codes out of the system and see how the transmission works. Hopefully that's all there is, because there could certainly be more problems than this. So we're going to go ahead and clear the codes now that the sensor's installed. Chrysler doesn't allow you to clear the codes while it's running. We'll clear that code, continue. While we're here, we'll go into the engine control and clear the codes in there, although the fan code is going to come back immediately. Oh, I don't have the key on. Alright, we'll go back into the tranny. It's funny, the tranny data stays live with the ignition and accessory position. There's the desired line pressure in PSI, and the line pressure sensor voltage, and the line pressure and actual PSI. So we're going to start it up. Well, desired line pressure is 125, and actual line pressure is 125, and the line pressure sensor voltage is fluctuating between 2.5 and 3. I'm not sure if that fluctuation is normal, but we're going to take it for a road test and see how the transmission works. So I just came back from about a 10-kilometer road test with a dozen shifts through all the gears, and everything seems to work just fine. Cruise control works, speedo works. Not sure about the engine compression brake he mentioned. Not sure what you have to do to activate that, but I'll let him worry about that. I'm just going to check it for codes. Inadequate element volume, clutch, fourth clutch. That's interesting. Now this has got a modified transmission in it. I don't see any issue. That code was there before. I'm going to find out what causes that code. Inadequate element volume, fourth clutch. So that has to do with the volume, the clutch volume indexes. Possible causes: broken fourth clutch return spring or dislodged snap ring, broken fourth clutch accumulator springs, hydraulic leak in the valve body, transmission solenoid, powertrain control module. Now this is a modified transmission, it is a tuned engine. We did not reset the clutch volume indexes, so maybe that's something we should do. clear the codes and then see what happens. So I'm going to do a quick learn. Probably going to tell me that I have to do it with the key on, engine off. So I'm going to turn it off. Must be running. Brake pedal must be pressed and the parking brake set during the entire procedure. Test will not run if codes are present. So let's clear the codes first of all. And of course I'll have to do that key on, engine off. Are you sure? Yes. Continue. And now we're going to turn the key off, back on. And under system tests, I'm going to do a quick learn. Must be running with the parking brake on. Move the shift lever to drive. To neutral. Do not release the brakes. Shift the transmission to drive. Do not release the brakes. Trip to park. Says completed. Let's go back and just see if it set any codes during that. No, it didn't. Well, I'm going to take this thing for another road test and see what happens. So there's the CVI data. I just come back from a similar road test. The transmission seems to shift perfectly fine. Let's have a look at whether or not it set any codes again. So that code did not come back. So I'm just going to discuss it with the customer. Maybe because of the transmission being modified. I know it's a stage 2, stage 3 rebuild. I think this is the second or third transmission in this truck because they keep doing them up. But that's it for now. Hopefully this thing stays repaired, and thanks for watching.